Greetings of the day to all, dear authors and invited guests. Welcome to our technical session at 12C. Myself, Prashi, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GIA Scholastics LLP, it is my great pleasure to welcome you to the 10th International Congress on Information and Communication Technology ICICT 2025, London, United Kingdom. The 10th edition of this conference was being organized in a hybrid mode. The physical event was held on 18th of February 2025 in London, United Kingdom, and the virtual event is being held through Zoom from 19th to 21st of February 2025. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentations and 3 minutes for the question and answers. On the 10th minute, I will be raising a gentle reminder. There is another request to all the participants that you stay connected to us till the closing remarks. If you have any queries or update, then you can write it to me in the chat box given below. Just before we start our session, I would like to introduce you all to our session chair for this session, Dr. Dharam Singh Jat. Professor Dharam Singh is a professor of computer science at Namibia University of Science and Technology. He is the author of more than 150 peer-reviewed articles and the author or editor of more than 20 books. His interest spans the areas of multimedia communication, wireless technologies, mobile communications system, edge roof computing, and software-defined networks, network security, Internet of Things. Sir, we welcome you to this session. Before we
Thank you.
start, yes,
Yeah,
sir.
thank you, Mercy. Thank you.
So before we start, would you like to say a few words to our participants today?
Yeah, thank you for your nice introduction and thanks for all the participants who joining these sessions. So just during the presentations, you have to concentrate on your methodology part as well as your outcome of the research because you have a limited time, only 12 minutes. I suppose 12 minutes is for presentation and 3 minutes is for the question and answers. Thank you.
Correct, sir. Thank you so much, sir. Now we'll start with our presentations without wasting any further time. I would like to call upon our first presenter. Give me a second. Our first presenter of this session is Sama Sambel, presenting a paper on the title Analysis of US Congressional History with Python, Insights from the 66th to 118th Congresses and Generational Trends. Ma'am, if you're available with us, I request you to kindly take over with your presentation, please. Ma'am Sama. Oh, I don't see Miss Sama over here, so what I'll do, I'll just call upon the next participant. Our next participant is Mahfouza Akhtar Jarin, presenting a paper titled Comparative Analysis on Predicting Price Hike with Sources Using Different Machine Learning Algorithms. I request you, if you are available with us, kindly take over with your presentation to the session, please.
Thank you.
Thank you so
I'm
much.
I'm taking over this presentation right now. Do I have to on my video cam or should I just present like this?
Not required, if it is whatever is comfortable for you, ma'am.
Okay, thank you. Thank you so much. I am very pleased to be here with you all in this morning. Good morning, everyone. Special thanks to all the authors, co-authors, reviewers, organizers, and all who are present here. I would like to discuss about our research topic on comparative analysis on predicting price hike with sources using different machine learning algorithms. First of all, we have 6 authors in our team: Tawfiq Hidayat, Anup Sen, myself Mahfuz Akhtar Zarin, MD Sohel Rana Shaun, Joybardhan Sarkar, and lastly Sada Anjum Shanto. This is an overview of our today's topics. I will provide a brief explanation on these. Price hikes are sudden increases in the prices of goods and services driven by factors like high demand, limited supply, rising cost, and geopolitical events. Predicting price hikes allows us to anticipate market shifts, manage uncertainties, and adapt to regulatory changes effectively. Our study's objective include analyzing current price fluctuations of the dollar and gold both domestically and internationally, conducting comparative analysis across datasets and applying machine learning algorithms for accurate prediction. Post prediction, we will evaluate accuracy using gold value as a benchmark and explore global causes of price hikes using diverse datasets for a comprehensive approach. This idea aims to detect early signs of inflation to aid socioeconomic stability. Rising costs in housing, healthcare, education, and essentials, driven by global conflicts and resource price hikes, are also putting pressure on living standards. Early inflation detection could help safeguard access to these essentials and support economic resilience. There are some hurdles that are going to get on our way throughout the project, which is difficulty in finding consistent dataset and synchronizing dataset as per domestically and internationally, also finding the proper platform for the analysis. In the past, researches have been done in prediction in which the interesting parts are that they have found out some of the best working models for forecasting prices of stock prediction, Bitcoin, housing, and cryptocurrency prediction. In this finding, they have come up with accuracy starting from 84% up to 94%. They have used LSTM, CNN, GRU, Reaper, and other predicting models. But still, there were some drawbacks to those studies, such as less accuracy, highest MSC, and limited amount of data to work with, which we have tried to overcome with better approaches. Our research workflow has four phases, which starts with dataset preprocessing, where we have our dataset from investing.com with nearly 4,000 data points across 7 columns. After this, we will go to the next part for handling missing data by using mean, median, imperative imputation to fill the missing values. But if it doesn't work, lastly, it will drop the null columns or rows. Furthermore, we will transform the data by converting strings to numeric value for easier calculation. Then we will add the weight and biases to the neural network and scale it to a standard using the min-max scaler. In the second phase, data serve, we will split the dataset into two parts, training and testing dataset, where we have used the 80 to 20 ratios. The reason behind choosing this percent is because when we have split the data into 70 and 30%, it was causing a big difference in the accuracy and overfitting issue. That is why we have chosen this portion. After the third phase is where we have trained the dataset using the LSTM, SVR, AdaBoost, BLSTM, GBRT machine learning algorithms. Then the last phase, finalization, where the trained and test data will be merged into the result modeling for further work. Then we will analyze the predicted outcome using the result analysis. Also, will evaluate the accuracy of the results as well. This is our sample dataset we talked about. Our research dataset comes from investing.com, where we use the data from January 1st, 2010 to August 1st, 2024. There are more than 3,700 data points across 7 columns. These columns are date, which represents the specific date from which the data is being recorded. Price shows the closing price of gold futures for a particular day. It is considered the final price at which the contract is traded. Open column in a dataset points to the opening price of gold futures for that day. It is also the price of the first trade of the day that occurs. High, it is the highest price reached for gold futures during the whole day. Low is the lowest price reached for gold futures during the whole day. Volume column indicates the volume of gold futures contracts traded on that day. Volume is the measurement of trading activity. Lastly, we have change. This column points to the percentage change in the price of gold futures from the previous day's closing price. It also indicates a positive percentage price increase while the negative percentage shows a price decrease. On the data preprocessing part, the dataset preprocessing includes handling missing values, normalization to ensure data consistency, and also data transformation to scale data, remove outliers, and select the features of data. For our project, we have used the algorithms like BLSTM, GBRT, SVR, AdaBoost, LSTM, and REST API. First of all, we have bidirectional long short-term memory, BLSTM or BiLSTM, which is a recurrent neural network that is able to process sequential data in both forward and backward directions. It works with a forget input and output gate by using the two LSTM networks and then combined to produce the final output. Gradient boosting regression trees or the gradient boosted regression trees GBRT model, also called gradient boosted machine or GBM, is a type of additive model that makes predictions by combining decisions from a sequence of base models. GBRT performance depends on key hyperparameters, learning rate, controls, step size, n estimators, sets, tree count, and max depth analysis adjust the complexity. Minimum sample split or the leaf prevent overfitting while subsample or max features add the randomness. Regularization L1, L2, gamma ensures conservative splits. Proper tuning balances bias variance for optimal results. After that, we have support vector regression SVR, which is a type of support vector machine SVM that is used for regression tasks. It tries to find a function that best predicts the continuous output value for a given input value. AdaBoost or adaptive boosting is a machine learning algorithm that combines multiple weak classifiers to create a strong, accurate predictive model. Lastly, we will use the machine learning neural network REST API to act as a bridge between applications and machine learning models. REST API is an architectural style that defines a set of constraints for designing networked applications. After that, predicting, we have evaluated our model on the basis of the evaluation matrix. These matrices are accuracy, which is the percentage of correct predictions, precision and recall, measures of predictive correctness, F1 score balances the precision and recall, and lastly R2 score and the MEC measure of fit and error rate. After analyzing the outcome from our machine learning models, we have AdaBoost and GBRT with the best accuracy of 99.18% and 99.04%. And the least is SVR with a 92.55%. In precision, the highest value is AdaBoost 0.9972 and the lowest is SVR 0.9253. In recall, highest value is BLSTM 0.9973 and lowest is SVR with 0.92. In F1 score, the highest value is from AdaBoost with 0.9918 and the lowest is SVR 0.9226. R2 score highest is GBRT 0.9966 and the lowest is SVR 0.9667. Lastly, the highest MSC is SVR 3187.94 and the lowest MSC is GBRT 0.15. After that, we have added the ARIMA or the SARIMA with model, which are time series statistical models, which the accuracy of 48.7%, precision 0.400, recall 0.3676, F1 score of 0.5602, R2 score of 0.992, and lastly MSC of 371.77. For our
Excuse me, ma'am, this is a gentle reminder that we have crossed our 10-minute mark. I just request you to kindly sum up your presentation as soon as possible, please.
Yes, thank you.
You may
GBRT model.
present your observations.
Okay. Lastly, we have selected the GBRT model based on the best accuracy, lowest MSC, hyperparameter, and overall performance. And we have found out that GBRT model is the perfect fit and well-balanced fit for our model. And lastly, we have compared the Ariman Sarima, which showed MSC of 371, 77 and R2 of 99.2%, but only 48.7% accuracy with 40% precision and 36.7% recall. Our machine learning models perform better than the time series statistical models. We have also used REST API to create a website interface where we have used the model to predict up to 120 days prior. While our research offers insights into factors affecting price movements, market prediction essentially involves uncertainties and external factors may impact accuracy. Future studies could enhance this by further exploring comparative analysis in price hike prediction. Lastly, these are our references that we have added for our paper, and thank you all for being patient with me.
Thank you so much, ma'am. Now I'd request our session chairs. Do we have any questions for her? Dr. Singh, Dr. Nanda?
Thank you, Maya for your nice presentations.
Thank you.
Is the presentation is clear that you compared all the machine learning algorithm. What
Yes.
about the KNN? Is KNN you also implemented in this analysis or not?
No, sir, we have not implemented KNN. We have conducted our research from the previous studies in predicting models. We have found out that the BLSTM, LSTM, GBRT, and these kind of models have been used very frequently. So we have tried to have a better outcome from these models.
Okay, one of your presentation, you told me the total is that you remove the outliner from your analysis. So
Yes,
you know
sir.
the machine learning we are using to include the outliner. If you remove the outliner, then the result will at par at like the Excel sheet or other informations. So why you remove the outliners?
Because they are the outliners that we have, it was creating a very big difference in the accuracy and the MSC. Because we know that MSC is the error in our data set. If we do not remove the outliers, it will affect our accuracy. As because we are focusing to have a very accurate and effective prediction from our models, that's why we have used our normalization, data transformation, missing value handling to have a better outcome from these models.
Okay, thank you, Ma'am, for your presentation. Thanks.
Thank you so much, sir.
I have a question.
Yes,
Namaskar,
ma'am.
everyone. Hannah, why you used this ARIMA model? I mean, if it is giving you results which are not as per your requirement, what prerequisites you have followed for it? I mean, have you gone through this test, all the prerequisites for this test?
Yes, ma'am. By we have used the ARIMA. After having the reviews that we should also compare our models with the time series statistical models. So for this we have compared and analyzed use the time series statistical model with our existing machine learning models where Sarima or ARIMA is used for understanding the seasonality and the trends with the help of XGBoost for accuracy and AutoArima for quick exploration of time series data. Where the MSC is 371 and the R2 score was 99.2%, but unfortunately, the accuracy is 48.7%, which is very low for our among our machine learning models. That's why we have lastly tried to compare these two models that from time series statistical models, our machine learning models have given us a better prediction outcome.
Okay. Overall, your presentation was very good. Very
Thank you
nice.
so much, ma'am.
Thank you so much, ma'am. Now I would like to introduce you all to our second session chair, Dr. Ruchi Nanda. Dr. Nanda is working as an associate professor and head in the Department of Computer Science and IT at IIS, deemed to be University, Jaipur, India. She has actively contributed in teaching and R&D for last 17 years. Her areas of expertise and interest are in research of big data, cloud computing, machine learning, and database. We welcome you to the session, ma'am. Thank you so much for joining us.
Thank you. Thank you.
Without wasting any time, now I'll call upon our first presenter who was unable to present, Sama Senbel, and paper titled Analysis US Congressional History with Python Insights from 66th to 118th Congresses and Generational Trends. Ma'am, if you're available with us right now, I request you to kindly take over with the presentation, please.
Yes, I'm right here.
Okay.
Can I share, please, my screen?
Yes, ma'am, please.
Do you guys see it now?
Yes, ma'am, we can see it.
Okay. Okay, good morning, everybody. So I'm here to present our paper entitled Analyzing US Congressional History using Python. We're going to look at insights from the 66th to the 118th Congress and generational trends. This work is by my students, Venkata Sai Varsha and Bhargavi Prodotri, and we are from Sacred Heart University in Fairfield, Connecticut. Okay. So our objective, this paper focuses on analyzing changes across the years in elections.
Sorry, can you put on the presentation mode? Not.
Oh, sorry. This is presentation mode, no?
Ma'am, sir is asking you to put it in the slideshow mode if possible.
Yes. Is
Yes.
it this better now?
This is better, ma'am.
Okay. This paper focuses on analyzing changes across the years in elections using historical election data to identify key trends and shifts. By leveraging Python-based data analysis, the study provides a quantitative assessment of how elections have evolved over the time. We aim to focus the highlights of the factors driving the change, particularly voter participation and party performance. Okay, so we use the Python language to actually collect data and analyze them from the current and previous participants in Congress and Senate right now. So we used Python-based approach. The code developed process the election results data to extract relevant features to some statistics and visualize a few trends over the years. We did use a few libraries from Python. We used the pandas for data manipulation. We used NumPy for doing the computations. And then finally, we used Seaborn for doing the visualization that we'll be showing you right now. Just to make it clear, this is the work of my students, not really my work. And this is just a very quick look at the outputs that we had. So this is just a quick look. So we looked at the Congress between 66 and 118, which is about the last 100 years. And for that, we used a party code. So as you know, here we have different parties in the States. So we had different codes for them between 100 and about 500. But mostly, really, it's two main parties, the Republicans and the Democrats. And then one of the features that we were looking at in particularly is the age. So there is a trend right now for the age of the Congress people right now. And we noticed that there is a very interesting pattern over the years. The age right now that we have varies between 23, which is the youngest person in Congress, and the oldest, which is 98. And this is a very interesting issue right now in the United States about how the Congress is aging over the years. So we start by looking at the youngest people in the Congress, and this is a very simple summary of our results. And as you can see, if you look at this one over here, this is the youngest person that we had, Clarence John McLeod, and his age when he went into Congress was 23 years old. And this is his birth date. So it was really a long time ago. If you look at those birth dates, right, you will notice that most of them really are pretty old. There's only actually two right now who are very young in Congress. Most of the younger people were in the long time ago, as you can see, 1906, 1938, 39, 1913, 18, 1921, and so on. So it's very rare to find actually a young person in Congress. So we have two of them right now. This is Madison Cawthorn. He left Congress, but he was 25 when he joined, right? He was born in 1995. And right now, the only youngest person in his 20s is Maxwell Frost from Florida, and he was born in 1997. If you look at the party affiliation, notice that most of them says 100, which is Democrats, right? So the vast majority of younger people tend to be on the Democratic side. And this is the number of Congress they were in, right? As you can see, the two young ones were 117 and 118, which is the current Congress right now. And this is the states they're from. They come from different states, but in general, it's pretty rare to find somebody this young. All of them are from the House, which is the lower house, not the Senate, which is the higher house. As you can see, all of them, of course, are men. It's very rare to find a woman. So this is looking at the younger people. Like we said, they are very rare. And this is the other side. This is the oldest members. Now, this is actually much more common. Just by look at this column over here, the columns. See, all of them really are 118, 113, 107. So it's much more recent Congress. So there is a trend that young people now are very rare, unless they were, and older people are more common. This is the names of the oldest one, James Truman. He was 98 at Congress, right? He's from South Carolina, and actually was very famous for actually being the oldest member. And then right now, who do we have? Dianne Feinstein from California. She's very famous as well. She won at 89. She is in Congress right now as we speak. We have Charles Grassley over here. He's 89 as well. He's actually a few months younger than her, and he is serving right now. So as you can see, there is a trend. You see here we have 1, 2, 3, 4, 5. In the recent years, to have older and older people representing people in Congress. And this is very clear by looking at the oldest and the youngest. This is a very simple chart showing the age distribution in Congress. And as you can see the trend, this is the age between 30 and approximately 80. And it's a very nice bell-shaped curve, right? With the average age around in the mid 50s, but still there's plenty of older people. And very rare would you find somebody under 30 or even between 30 and 40. Now let's look at comparing the House and the Senate. Now remember, the House is the lower house, the Senate is the higher house. So we see that we have here less members, and also the age trend, this is roughly around 60. This one is still very high, around 54 or 55. Once again, having somebody very young, under 30, is very rare in the House, and it's non-existent in the Senate. The Senate, the youngest people are around 40. So there is a very interesting trend in that people in Congress are generally older than general population for the US. And now let's look at the different generational shifts, which was really our interest. So this is looking at the different Congresses in the last 100 years, right, between 66 and 116. And each color represents a certain generation. So these boomers are the people who were born between the 40s and the 60s, right, in blue. as you can see them over here, they are currently the majority of people in Congress. And you see a trend over the years, their percentage keeps on growing and it's not really dropping. It should have dropped already, but it is still high. It is just starting to drop in the last Congress. So they are kind of dominating right now the Congress. Gen X is the people between in the 70s and 80s. And as you can see, this is orange over here. They are really just, increasing in numbers. Those are people who are right now at least, like 40 years old. So they are pretty old. You don't really see much of the younger people. There's like 3 or 4 of them. So it's not really showing in this chart. But in general, every generation, they tend to pick up and then they stay high for a very long time before finally kind of, dying off. This has been a trend in general. If you look at this group in purple over here, right? So you can see how they were growing over the years, and then this is their peak, and then suddenly the numbers drop down rapidly. So every generation seems to take like, a peak time and then very quickly drop towards the end. They kind of try to hold on as long as possible, and you can see it in this chart among all generations. It usually is kind of growing quickly and then a sudden drop when, I guess, when they get older and they get elected out. Okay. Now let's look at the different parties in the Congress. So this is looking at the timeline. So this is time as well. This is the last 100 years. So this is Congress 66, roughly 1919, until the current Congress right now. So we're looking at the current trends in the who's winning and who's losing. So this is looking at the House. As you can see, the Republicans dominated for a very long period, right around the Cold War and after World War II and so on. And right now you see a very interesting trend in that the number of members are becoming very close. So since roughly the early 70s, Congress has become closer and closer rather than having big gaps like you have here and here and here. Right? You can see that the difference is 1 or 2 members. And right now, as we speak, it's just literally 1 member. So this is actually a good thing that there's more balance in the Congress. You can see over here right now, the Democratic Party, but actually last November, right now the Republicans win by actually 1 point. So this one is now higher than this one. But in general, the number of members are really very close in the last 20 years or so. And the same pattern is actually reflected in the Senate. But actually, the Senate has been closer since roughly the early 70s. As you can see, the difference is getting smaller and smaller over the years compared to this time period over here, where we had really a very strong majority over time. So there really is a trend towards having both parties being more or less close in numbers. And unfortunately, most of the people are getting older and older. And it's very rare to get somebody young. By young, we mean like under 40, getting elected in Congress. So this is a trend in the United States right now. Like we said in our time analysis, we had different time periods for this one. If you look at the period, the first period represents really the World War One and the Great Depression, right? And this one was very big differences between Republicans and Democrats. The next part was the sessions between 80 and 93, which represented the timeline after World War II, the civil rights movement, and the emerging shift in political dynamics. And then the next part between 1975 and 2001 really looks at great change in the world in that time period. We're looking at the effect of the end of the Cold War, economic changes, and different, countries rising and so on. And different political polarization became very popular in this time period. And
Excuse
then
me,
the
ma'am.
last few years,
Sorry
yes,
to interrupt. However, we have this is a gentle reminder. We have crossed the 10-minute criteria mark.
yes, I'm
I
going to finish
request
right
you to.
now.
Yes, thank you so much, ma'am.
Yes. And then the last one shows the current period. Okay, so the result showing that there is a generational shift within Congress, with older people maintaining their dominance. And this raises important question about the implication for this, having older people take all the decision with very little representation from younger voters in general. Okay, and thank you very much.
Thank you so much for your presentation, ma'am. I would like to ask our session chairs, Dr. Singh or Dr. Nanda, do we have any questions for ma'am? Sir, I think your mic is on mute right now. One second.
Oh, sorry.
Yeah.
Thank you for your presentations. Just we know the methodology, how and one of the slides I think the youngest youngest age of the congregator is 23 age and the oldest is 98. But in
Yes.
your graph, I show is the minimum is 30 and the maximum is 80. So did
Yes,
you
actually,
remove the
because it's only
outliner or not?
one. Yes, it's only one person, so he's not really showing on the graph.
Okay,
He's the
okay.
only one who's
So,
under 30. So in the
so you
graph,
have not
it's
measured the average persons in that particular age. So you. So
the
what was
average
your
is about
measuring metrics? How you measure those things in using Python or the machine learning algorithm? Because
yeah,
I
we did.
cannot see the methodology part in the presentation.
No, we didn't. We're only showing the results because of the time period. We used
Oh,
the NumPy library for doing the
okay.
analysis and drawing the charts.
Okay, thank you. Thank you, madam.
Thank you.
Dr. Nanda?
No, it's a good presentation.
Okay. Thank you very much.
Okay.
Thank you so much, ma'am. Ma'am, I request you to kindly stay along with us because I suppose the next presentation is also from you. I would just announce the title. The paper title is Northeastern United States Traffic Accident Trends, a Geospatial and Statistical Analysis using Python. Ma'am, are we ready with the presentation for this
Yes,
title?
I am. Yes,
Yes,
yes, I
okay,
am.
ma'am.
Can you stop sharing so I can
Yes.
share? Okay. Okay. Can you see it now?
Yes, ma'am, it is visible.
Okay, so thank you very much. So this is work by my students as well. It's not really mine. So the students are Sadvik and Tejani, and I was their professor. So the topic is same thing. We're analyzing really trends in data. So the paper title is Northeastern U.S. Traffic Accident Trends, a Geospatial and Statistical Analysis. So once again, we're using Python to do some analysis on our data about the Northeastern U.S. Okay, so this presentation explores traffic accident trends in the Northeast United States, focusing on Connecticut, because we are in Connecticut right now, and the neighboring states, which is New Jersey, New York, Rhode Island, Massachusetts, right, the Northeast part of the United States. This is a very crowded part of the United States with lots of roads and highways and so on, and lots of business traffic in this area. So we're using data analysis and visualization using Python as well. Like you said, we used different libraries in Python for visualization, mostly Seaborn. And then we have some numbers to show you guys. We're just showing the results here, not really the methodology. So I'm sorry about that. So we look at the different factors that really affect accidents. We look at the risky driving behavior and then the accident outcome, how bad was the accident, and then we look at how insurance is affected by all of this. So our goal is to look at what we can do, to implement road safety and looking at the policy decisions. So we started by collecting data from the website, which actually there's a website through the University of Connecticut where every single accident is actually stored day by day. And we collected it for the last few years. So we collected it from that website, which is, like I said, hosted by Connecticut University. And then we did some cleaning by literally throwing away some of the detailed fields about the people, details like that, the color of the car, stuff like that. We only really looked at the severity of the accidents and what caused the accidents mainly. And then we looked at the insurance and how it was paid. We used pandas to access the data. We used matplotlib to draw. And this is the visualization that of our results. Okay, this is just looking at the numbers quickly without much details. So roughly, we have about 10 fatal collisions per 1 billion miles driven. We have about 36% of alcohol impaired are in fatal collision. A fatal collision is a collision really where somebody dies. This is kind of, if you will, the most kind of the worst type of accidents. We look at the speeding, about 46% of drivers in fatal accidents were speeding. And then the insurance premium was about $1,000 per car. This is for the state of Connecticut. Okay, Now, if you look at comparing Connecticut to the neighboring states, which is kind of supposed to be a relatively quiet state. So if you look at speeding, we'll notice that about 46% we said were speeding, but neighboring state actually it's much lower. If you see that, notice that New Jersey has the lowest speeding at about 16%. New Hampshire is the highest one with 35%, and New York is roughly the same as Connecticut, which is 32%. So we notice that we are pretty high relative to the Northeast area, followed by, uh, sorry, higher than us are New Hampshire and New York. So this is really pretty bad. We do have a lot of speeding, I think mainly because of we're a very quiet state, if you will. So the streets kind of really encourages speeding. Now, this is another problem that we noticed is the alcohol impaired. So looking at all those fatal collisions only, we noticed that Connecticut actually among our area really has the highest percentage of, alcohol impaired drivers who are involved in fatal collisions. So this is our state, Connecticut, at about 36%. Massachusetts is very close at 35, and then you can see that the other states are much lower. So this really shows that Connecticut has an issue with, driving. So this really needs to be more enforced and more kind of taught better about, driving while alcohol impaired. It's a very obvious difference. Another thing, we looked at the percentage of distracted drivers, right? So distracted is not, they were not drunk, right? But they were actually, doing something else, maybe using their phone or not paying attention to driving. So what we notice is about 87% of people were not distracted, which is very similar to everybody else. And interestingly enough, 82% of drivers in fatal collisions did not have any accidents at all, which is very good actually. And this is very similar to New Hampshire at 83%. So really it shows that you can have like a very clean record and suddenly you're involved in a driving accidents. But you really cannot do much about this distracted one. You cannot really have a class for, taking care of this. This is unlike speeding or the alcohol impaired. And as we noticed that all of the states are very consistent in this distracted driving practice. So roughly they are between 86 and 88%. So not really much difference between the states. This is comparing it to the alcohol and the speeding. Okay, now this really affects how much insurance that you have. So in the United States here, how much you pay for insurance depends on if you had an accident or not. And this is usually also trend with, it's really depending on different factors such as where you are. So this is the names of some of the famous, companies that pay for insurance. And whenever you have an accident, usually your premium goes higher and higher, not just for you, but really for the whole area. So the effect is that when you have accident, you would typically have higher premiums. You will have to pay more and more. So Connecticut has a relatively high average insurance at about $1,000 each, which is really the second highest after New Jersey. This is because of we have so many accidents here because of preventable stuff like, speeding and alcohol impaired. Now, also the insurance company in our part of the world, they really have to pay significant losses because of all those accidents. So they roughly pay about 167 in losses per insured vehicle. Right? So you're paying about 1,000, maybe 500 to $1,000 per car. And then because of the very high rate, we typically pay about 167 per car, even if it's not in an accident. And this is really not a good thing because now we have to pay more and more for other people's mistake if you. So the high premium and those losses correlate with elevated rate of speeding and alcohol impaired, which really can be fixed by doing, by teaching people more and having more police on the roads and so. So this is really what we advise, having better, sensors in the car to hopefully, minimize number of accidents, having traffic management to optimize the traffic flow and control speed and so on. And then looking at the real-time tracking of driver habits. This is by sensor during the car, hoping that to minimize the distracted driver accidents. So this would be something that you would install inside the car. So this is the new trends in road safety management, hoping to minimize the number of fatal collisions. Okay, so like this is the policies that we think would really help to enhance speed enforcement, to promote the intelligent transport systems in cars, to strengthen the DUI prevention, by having, different classes and teaching people, and to look at the insurance model really to incentivize people driving better. So the better you drive, the less you have to pay for insurance. Okay, I'm done. So in general, right? So we really have lots of fatal collisions per mile, which is not a good thing. And really the main challenge is in speeding and alcohol impaired driving. And this really affects the high insurance. So our recommendation from this analysis is that we really need to look at the data insights and work about the targeted interventions for speed and for alcohol in particular, and to continue looking at safety and to work with neighboring states to see how they are, getting better results than our state. Okay, and this is our leverage of this paper. Okay, thank you.
Thank you so much, ma'am.
Thank you.
Dr. Singh, do we have any questions for her?
Yeah, thank you. Thank you, Samya, for your presentations. Most of accident is related to the alcohol and the speed. So is
Yes.
there any correlation between the speed and alcohol in your study?
Actually, yes. So we said about 36% of people were speeding, right? And about 24 were doing alcohol. We did found about 10% were actually both of them. So that was a relatively smaller group. So there is a
Okay.
correlation, there is an overlap between those two groups. But it is in
Okay,
general
so
higher than the comparative states.
no, this reading is fine. 36 and the 40 is fine because there are two components. One is the speed, another is the alcohol.
Yes.
So is there any significant correlation in between two? One people is
Uh,
have speedy as well as the alcoholic.
Actually, we didn't look into that right now, but we noticed that
Because
about
this is
10%.
important. This is very,
Yes.
very important. Once you are driving, then mostly alcohol will people increase their speeds.
Right. Yeah, we
So
didn't look
so
into
when
that, but thank you. Yeah,
yeah.
we should look into
Okay.
that. Yes, to
Okay,
Yes,
see.
thank you.
correlation between the variables that you have taken. And that is the
Yes.
best thing if you want to analyze any particular problem. Like you have taken this problem, this is for definitely for the societal benefit, right? And now, what is your future perspective? What you will going to do now in as your future research?
Right. So
Are
like
you,
we said,
yes, do you want to apply certain kind of prediction models or
yes, so right now this data set is hosted by the University of Connecticut, which
yes,
actually correlates with the police of the state. And they
yes.
actually they want to analyze this data. So part of the work is they publish the numbers so that other people can show them, charts and analysis and so on. So I think this correlation would actually be an interesting second step for us.
Okay,
So yeah, hopefully we'll do that in the future and
right.
upload it to the website for the police.
Definitely. Very nice
Thank you.
presentation.
Thank you.
Thank you so much for your presentation. Now I would like to call upon our next presenter for the session. Our next presenter is Dwangliani, MS, presenting a paper titled Predicting Breast Cancer Recurrence Using Hybrid Machine Learning Algorithms, a study on Mizoram State Cancer Institute data. If you are available with us, I request you to kindly take over with your presentation, please.
Yes, ma'am, I'm available, but right now my Wi-Fi just cut off, and I'm connecting from my phone, and still I'm try my presentation since I put it in my laptop. So I don't know whether I can share my slides from my phone.
Ma'am, do you have that copied in your phone somewhere, the presentation?
Maybe next presentation can continue the related adjustments
Yeah.
until it can be done.
Yes, yes, we'll do that. Ms. Wangliani, if it is a problem for you, you can just mail it by any chance to our team, or you can send the presentation on the chat to me. Meanwhile, we'll take up the next presenter. Is that okay for you? Okay. So seems like she has left the chat, so no issues. Maybe after a while, when things are better for her, we'll take her up. Just a second. I'll just introduce you all to ma'am first,
Okay.
before you start sharing. 1 second, ma'am. I'll just introduce your paper as well. Kangsu Kudem Ekin, presenting a paper titled Preliminary Assessment of ICICT Based User Acceptance Model for the Key Desk Facility Management System in Healthcare. I just have introduced her. Ma'am is already here with her presentation. We'll just start with the presentation now.
Yes. Thank you very much. I will start sharing with my presentation. Okay. Thank you very much for all for your attendance. The title of our presentation and paper, Preliminary Assessment of the UTAH-based User Acceptance Model for Key Desk. It's a facility management system in healthcare settings. And I'm Cansu Çiğdem Ekin. I'm working in Atılım University in Computer Engineering Department. In the presentation, I will start with the introduction parts. I will define health specialty management system. Then, in the next part, methodology, in the scope of methodology part, I will inform about KDESK system and how we collect the data and the analysis was done and how we evaluate our measurement model using UTAH system. And I will finish with the conclusion and discussion parts. Health specialty management is a multidisciplinary field and ensures functionality, safety, efficiency of the healthcare environments by integrating people, processes, and the technology. And it plays critical role in supporting healthcare organization cooperation, such as maintenance, cleaning, operational workflows. The operational phase of the healthcare specialty life cycle is most resource intensive and accounting for approximately 60 or 85% of the total life cycle cost. Within this context, computerized maintenance management system CMMS, and integrated health specialty management solutions such as KeyDesk, which is evaluated in the scope of this study, have emerged as a vital tool for optimizing maintenance and enhancing resource allocation and improving overall efficiency. The adaptation of the health specialty management technologies often faces some challenges like user acceptance. And despite the critical role of this type of technologies in healthcare environments, research focusing on the factors influencing their adaptation and acceptance remains limited. For that reason, we evaluate the applicability of the UTAH framework in this healthcare settings using KDESK system. UTAH is a framework and evaluation of the earlier models like TAM, which is named Technology Acceptance Models, and it provides a robust framework in organizational context by integrating its constructs. And these constructs, as written here, social influence, facilitating condition, performance expectancy, behavioral intention, and effort expectancy. Within this context, using these constructs, we try to address this research gap by applying the UTAH model to evaluate the user acceptance of the our technology management system. It's a healthcare facility management system used in healthcare settings. And the research focus on assessing the reliability and validity of the UTAH constructs, which is given in the previous paragraph. By doing so, this study not only tests the applicability of the UTAH in unique context of the healthcare facility management, but also contributes to the broader understanding of the technology adaptation in healthcare environments. Mainly, this study evaluates the user acceptance of the KeyDesk, which is a facility management system for healthcare settings, and which is implemented for a major city hospital in Turkey. KeyDesk is a special software and it's designed to optimize facility management processes, including maintenance, resource allocation, and operational task management. This system has been deployed in a healthcare setting, as I said before, and where its adaptation is critical for streamlining complex workflows and improving overall efficiency. To present a clear overview of the hypothesis relationship in this study, a PET diagram was created using UTAH framework. And this diagram visually represents the conceptual model, including direct relationship among constructs, as seen here. And we used 5 different constructs as given here. And for each one, PE stands for performance expectancy, and the extent to which user perceive that KDesk enhance their job performance. EE stands for effort expectancy, and it represents the extent to which KeyDesk is considered user-friendly and easy to navigate. SI represents social influence, and the extent to which users feel that influential individuals or groups encourage their use of KeyDesk. FC represent facilitating condition, and it represents perceived availability of the resources and the support necessary for effective use of KeyDesk. And the last one was behavioral intention, and shorted as BI, and it represents users' intention to continue using KeyDesk. And then the look data collection parts. Data were gathered using a structured survey administered to healthcare professionals, including doctors, nurses, and system operators actively using KeyDesk system. And the data set includes a balanced gender distribution as seen here. 51.4% was female and the other one was male. And the majority of the users, which is given as 68.8%, having over a year of experience using KDesk, and mandatory user constitutes 75.6% of the respondents, while the remaining one are voluntary users. Most participants hold a bachelor degree and primarily work in administration related roles. Sorry. And the survey items were derived from validated UTAH skills and translated into Turkish through a back translation process to ensure both linguistic and conceptual consistency. And the back translation process was validated by having the survey items translated into Turkish, then back into the original language by independent bilingual experts. Differences were reviewed and resolved to ensure the items were both accurate and culturally relevant for the Turkish context. Each constructs were assessed using a 7-point Likert scale. And out of 2,547 initial responses, 2,268 valid responses were retained after excluding outliers, and we started to our analysis. As seen in this slide, we had two different parts in our survey. One was related with related construct items, as given here. For each construct, for each 5 different constructs, we have 4 or 3 different questions, as given here. For the moderating variables, we also ask the respondents' age, their experience, their departments, and the related user type also in this survey. And for the analysis, for the survey answers, we use PLS SAM to analyze the related survey answer. We choose this software because we had a large sample size. For that reason, we prefer to use this program in our analysis. And for the UTA evaluation, for this framework evaluation, we check construct reliability, construct validity, and model fit indices to ensure the robustness and the accuracy of the proposed theoretical framework. And to assess construct reliability, we check internal consistency among constructs. For the construct validity, we also check different theoretical dimension. The overall alignment of the measurement model is evaluated with model fit indices. And the related measurements model evaluation was done according to the criteria given in the literature. And when we look...
Excuse me, ma'am. This is a gentle reminder. We have exceeded our 10-minute limit. So I just
Okay.
request you kindly wind up as soon as possible, please.
Thank you very much. This is the result part of the study. And as seen in the table 1, to verify the construct reliability, the following metrics were evaluated as seen in the table 1. CA represents CROMVA alpha value, and CR represents composite reliability value. And according to the each value given here, all of them was above the threshold value, which is 0.7, and it represents acceptable reliability. According to the CR value, composite reliability value, all constructs showed that CR values above the recommended value, again, which is 0.7, and it validates powerful internal consistency between constructs. And then we look validity of the constructs as given in table 2. According to the convergent validity measurement, we evaluate the related validity using 2 different criteria. The first one was outer loadings. And according to the outer loadings, item loadings on the respective constructs were inspected, and all loadings satisfied the recommended threshold value as given here. All of them are above threshold value of 0.7 again. And when we look the other indices related with the model measurement, for the validity of the construct, we need to check discriminant validity and cross-loading. And to check discriminant validity, we can use Fornell-Lecker criterion as given here. And the as seen here, according to the Fornell-Lecker criterion, we met for all constructs, confirming that the constructs are unique and the measurement model achieves the adequate discriminant validity. and the highest observed correlation between behavioral intention and social influence, and remained below the variance threshold both constructs. Additionally, all inter-construct correlation were lower than the respective thresholds, and further verifying the model's discriminant validity. Okay, for model fit indices, as seen in the table, the results collectively confirm that the measurement model fits data well and meeting and exceeding the all recommended thresholds for PLS-SAM fit indices. The model's strong fit supports validity of the relationship hypothesis within the theoretical framework. As a conclusion, the technology used in healthcare setting is increasingly widespread. The adaptation of the e-health services, such as KDESK, is affected by factors such as awareness, medical education, expert opinions, government policies, and medical knowledge. Understanding healthcare professionals' intention to adopt technology is important for successful digitalization of the healthcare organization. Within this context, preliminary findings indicate that the preliminary findings of this study indicate that the UTAH model is well suited for the application in the context of healthcare organization management, and the adaptation intention of the healthcare workers are influenced by key factors. These findings indicate that it will be beneficial for healthcare organization to consider UTAH model when planning and implementing their technology investments. On the other hand, the use software, which is named PLS-SAM, enabled effective analysis of the large data set, addressing challenges in factor extraction and model complexity. In the next stage of the study, more comprehensive analysis with a larger sample and interaction of the different variables are planned to examine. By analyzing these elements, it becomes possible to gain clear insights into the determinants of the technology acceptance in healthcare settings, and to design more impactful implementation strategies. Thank you very much for your listening. If you have a question, I want to answer that.
Thank you so much, ma'am. Sir, do we have any questions for her?
Yeah, thank you. Thank you for the presentations and the application in the healthcare. Which technology you used for the data analytics in this study? Statistical or machine
Technology,
learning?
we use a specific software to analyze the survey data, and it was PLS. It's named as a PLS. It's a specific software, and then we give our CSV files, including our survey data. The related data was analyzed according to the settings given in this software.
So which software, SPSS or other softwares?
It's similar to SPSS, but it's special for large data sets, PLS-SAM. It's named PLSL, SAM analysis. It's for a specific algorithmic evaluation.
Okay, is it a proprietary?
It's structural equational modeling. Maybe you know it. It uses structural equational modeling algorithm to analyze this survey data, to find the relation between constructs, or is there any covariance or relation between constructs. It uses squared equational models to make this analysis.
How much was your data set size?
Sorry?
How much was your data set size?
It's above than 2000.
Okay. Okay.
Thank you very much.
Thank you so much.
Thank you for
Now I
your
would
listening.
like to call upon our next presenter. Our next presenter is Kongxin Shong, presenting a paper titled Relative Learning Contents, Difficulty Analytics System Between Learner and Learning Contents. If you are available with us, I request you to kindly take over with your presentation, please. Sir Chung. Okay. So I see Sir Chung is not here in the meeting right now along with us. So we'll take our previous presenter, Dwangiliani MS, presenting a paper titled Predicting Breast Cancer Recurrence Using Hybrid Machine Learning Algorithms, a study on Mizoram State Cancer Institute data. I hope your network is a bit better right now. Miss MS?
Am I audible?
You're audible. Can we start with your
Yes,
presentation? Is it possible? Should I present it for you?
I think you can speak the methodology and the outcome without presentations if you are
So
unable.
I do have her presentation along with me. She has shared it to me. Ma'am, do you want me to present it for you right now?
yes. Am I audible, ma'am?
Yes, yes, you're audible. Can you present it
Okay.
yourself or you want me to present it for you? Or so you can present it. Okay. Yes, it is
Can you
here.
see it?
Yes, yes, it is here.
Okay.
Is it possible for you to put it in slideshow? Okay.
Yes, yes, yes. Can you see it, ma'am?
Yes, ma'am.
Okay, my topic is presenting breast cancer recurrence using hybrid machine learning algorithms, a study of Mizoram State Cancer Institute data. And I'm Dong Liani, Dr. M.S. Dong Liani, and I'm assistant professor in government Zirti Residential Science College. And I'm presenting, I have two co-authors, and I'm presenting on behalf of my paper. And first we'll go to the introduction. Breast cancer rank the most common diagnosed malignancy in women worldwide, and this present a significant challenge to healthcare system and necessitating the development of effective cancer accounts for 13.5%. The 5 years age standardized relative survival rate for breast cancer in Mizoram is 74.9%. And we have collected data from Mizoram State Cancer Institute, and which contains 23 attributes and 575 samples. This is a 3-year sample data which we can collect it from the institute. And after getting the data, we have pre-processed the data, and in pre-processing, it underwent a cleaning process in which missing values, outliers, and inconsistencies were handled, and missing value were regenerated using statistical methods such as mean or media imputation for numerical variable and mode imputation for categorical value. And we have categorical value were encoded while numerical value were standardized to ensure uniform scaling. And data, we have transformed it to make the most critical predictor for breast cancer recurrence, reduce dimensionality, and improve model performance. And out here we have introduced in our prediction, we have 6 different classifiers such as J48 decision tree, Navy Bayes, multilayer perceptron, SMO, and KNN, K nearest neighbor, and finally the random forest. And we'll just look into some of the details of the classifier, that is J48, which is the most common decision tree, which is the most common classifier. And here we construct a decision tree by iteratively segmenting the data into subclasses based on feature value, thereby generating branches that leads to decision nodes that represent different outcomes. And here in our studies, it produced the most accuracy. And we are going to see it in the conclusion part. And here we have Navy Bayes. This is as we all know, it's a probabilistic classifier based on Bayes theorem. And in this Navy Bayes, in breast cancer prediction, Navy Bayes is particularly useful when data set contains both continuous and categorical features. For instance, in the Wisconsin breast data set, Navy Bayes can handle features like radius, texture, and smoothness effectively, classifying tumors as benign or malignant based on the computed posterior probability. And despite its simplicity, Navy Bayes have been shown to perform competitively with more complex classifier like SVM and random forest. And next we have MLP, multilayer perceptron, and this is an artificial neural network with multiple layers. And here in MLP, it composed of several layers, including an input layers, one or more hidden layers, and an output layer, where each neutron in one layer is fully connected to every neuron in the subsequent layer. So when applied to certain breast cancer data set, MLP can classify whether a tumor is benign or malignant based on the features that we have provided. And I'll not go into detail of this. Next is the SMO, that is sequential minimal optimization. It's a popular algorithm which is used in classification again, and it is widely employed for breast cancer prediction. They're effective in identifying a hyperplane that optimally separates data into distinct classes such as malignant or benign tumor. In breast cancer data set, it optimized the SVM objective function by breaking it down into smaller subproblems and solving each problem analytically. And it significantly reduced the computational complexity of training in an SVM. And we have KNN. It's a K nearest neighbor, which is one of the simplest and most common employed machine learning algorithm for classification tasks, including predicting breast cancer outcomes. The KNN operates by classifying data based on the majority class among its K closest neighbor in the feature space. For breast cancer recurrence prediction, the goal of which is often to determine whether the tumor is benign or malignant, KNN uses features such as cell radius, texture, smoothness to make prediction based on the closest data points in the training set. And we have lastly, we have the random forest, which is an ensemble learning algorithm that has gained widespread use in classification tasks, including breast cancer prediction. It utilized an ensemble of decision tree during training, aggregating their prediction to improve accuracy and robustness. And each tree in the forest was trained on a random subset of the data through bootstrapping, and at each split, only a random subset of feature was considered. This randomness helped to reduce overfitting, a common problem with individual decision tree, and enhance the generalization ability of the model. And in this study, taking all the 6 classifier into consideration, we combine the classifiers. That is, firstly, we combine the random forest and KNN, and in the next we have combined random forest and J48, and the same way random forest plus J48 plus Navy base, and at some point random forest, J48, Navy base, and MLP. Then we add SMO. Like that, we are combining all of them. Okay, so as to improve the accuracy. And the data set was split into training and testing subset using a stratified sampling approach to ensure that the class distribution of breast cancer recurrence was preserved in both the subset. And we have 2 primary evaluation strategies were employed, that is test strain split and tenfold cross-validation. And in train test split, the data set was divided into training set, that is 75%, and a testing set 30%. And the model were trained on the testing set and evaluated on the on the training set and evaluated on the testing set. And in the second approach, we have tenfold cross-validation, in which the entire data set was divided into 10 equal parts, and each part was used as a testing set, whereas the remaining 9 parts form the training set. This process was repeated 10 times, and the average performance metrics were calculated to ensure a robust evaluation. And the precision metrics used to evaluate the classifier includes accuracy, true positive rates, false positive rate, precision, recall, F measure, and area under the receiver operating characteristic curve, that is ROC. And this is the experimental result. And on the training set, in the training set, we have 100% accuracy in random forest, KNN and decision tree, and random forest and decision KNN, random forest, KNN, and J48. And this is the chart which represents the above table. And this one is the performance using tenfold cross-validation. Yeah, and in this tenfold cross-validation, we have the highest accuracy when we combine random forest and decision tree, that is J48. And here it has a true positive rate of 0.824 and a false positive rate of 0.403, precision of 0.821, and recall of 0.828, and F measure of 0.
This is
Yes.
a gentle reminder. We have exceeded our
Okay.
10 seconds.
Yeah. Thank you, ma'am. It's almost over. So this one is the chart representing the above. Now we will go to the last slide, that is the discussion and conclusion. As we can see, the hybridization of random forest and KNN classifier with other base classifier contributes to an increase in the performance of most classifier, and the highest performance was achieved by combining the random forest with J48. And despite this finding, the performance of J48 alone is 84.2105, which was significantly higher than that of the hybrid approach. Hence, we can conclude that the breast cancer data from the data set, the performance accuracy of J48 is the highest compared to all other classifier. And through the exploration of various classifier and ensemble method, we demonstrate the potential of this algorithm to enhance prediction algorithm and inform clinical decision making process. So our findings suggest and classifier show promise in improving performance. The J48 classifier emerged as the most effective predictor of the breast cancer recurrence in this context. And in the future work, enhancing the model reliability and applicability requires validating its performance on a larger and more diverse data set, which would perform its robustness and enable broader generalization to different populations. Furthermore, a comparison with cutting-edge technology in breast cancer prediction showed that while hybrid model, including random forest and decision making exhibit competitive accuracy, integrating advanced approach such as deep learning could potentially yield better outcomes. And the voting ensemble crucial for boosting model accuracy, applied equal weights across classifier to ensure balanced output. So these are all the things that I can say. Thank you so much.
Thank you so much for your presentation, ma'am. I would like to ask our session chair, Dr. Singh, Dr. Nanda, do we have any questions?
Yeah, thank you. Thank you for your nice presentation. Why you have not used the CNN in your simulations? You have compared all the machine learning algorithm. Hello, I'm audible.
Sir?
Say again. Have you used the CNN in the simulation?
Yes, I cannot hear you properly. Yes, today and then I have used KNN.
Okay, KNN. So how many hidden layers used in the simulation, the experimental study?
Pardon?
You see, there are a number of hidden layers you used in the simulation.
Mm.
So how many hidden layers used
You're asking.
Yeah, number of hidden layers. Okay, what are the significant attributes in your study? You used the 23 attributes for the simulation. So which one is the most significant for the breast cancers?
Yes, here in the data set, the attributes, the which contributes most is the stage of the, which is stage of the cancer. It has a high, it has a highest contribution towards the answer. That is, if the stage is high, then the recurrence and the recurrence chance is the highest.
Okay, thank you.
You have used Becca tool for the machine learning part, right?
Pardon?
You have used Becca tool for the machine learning?
Yes, ma'am.
Not used any Python packages. It's based on tool, right?
Yes, actually for this presentation alone, I have used Weka. Python, I do not use for this paper.
No, not for paper. It must be some part of any project? Is it a part of project or something?
Yes, we are doing research.
Yes.
Yeah, and it's a part of that research.
Okay, if you can use, programming language like Python or packages you can use, maybe you can get certain different type of results, and you can analyze in it in a different way. It's okay at the basic level, you can use Weka, but definitely for your further work related to
Yes.
different kind of algorithms, or you can say variables. You can use packages
Yes,
and
yes, yes.
perform your
Yeah, that
work with. Yes.
yeah. Yeah, that's a good suggestion, ma'am. I'll try to use some other tools.
Yes, yes.
Thank you, ma'am, for the suggestion.
Okay, thank you for your presentation.
Thank you so much
Thank
for
you
your
so much.
presentation.
Thank you, ma'am.
Thank you, ma'am. Now, with this, we come to the end of our session. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this 10th version and all the other previous 9 versions of this conference. We'll be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificate through email within the 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICICT 2025. I would also like to thank our session chair, Dr. Nanda and Dr. Singh. We have a small token of appreciation from our team for both of you, ma'am, sir. I'd just like to present it to you. This is a token of appreciation for Professor Singh. Sir, would you like to end this session with your remarks for our participants?
Thank you, Prasi. Uh, uh, I have the honor to take the floor of the technical session 12C of ICICT 2025.
Yes.
We would like to thank you for you very hard work for this session. Chairs, moderators of the moderator of the secretariat and the wonderful presenter who make all this happen. We have had some lovely discussions within the analysis and the predictive using machine learning and other emerging technologies in the various applications. Again, we would like to thank to authors, presenters for making ICIST conference a great success. Thank you.
Thank you so much, sir. Thank you so much for being a part. We have our next certification for Dr. Nanda. Just a second. Thank you so much, ma'am, for for chairing this session. Would you like to close with your remarks, ma'am?
Thank you so much for honoring me for this session as a session chair. I want to thank uh, Dr. Amit Joshi for this kind of opportunity, and definitely I'll congratulate all the presenters who have presented their research work in this prestigious conference. And we all have enhanced our knowledge with all the research that is going on in the field of AI and machine learning. And I hope you all agree with me. And thank you to the organizers, and thank you to Dharamveer sir for your wonderful suggestions for the participants. Thank you for.
Thank you so much, ma'am. Now, I just request all of you all present over here in this session 12C to kindly switch on to your cameras so that we can have a quick snapshot of this session and keep this as a memory. All present, I request you to kindly please switch to your cameras so that we can have a quick snapshot. Thank you so much. Thank you so much for being a part of this session. Thank you.
Thank you all.